Hi, I'm Jawad.
Hi, I'm John,
Hi, I'm Nahil.
and today we're going to show you how the helium neon laser works.
The core components of a helium neon laser include a glass chamber, our helium and neon gas mixture, a partially reflective mirror, a fully reflective mirror. Now, to supply energy to the system, we'll be using a high voltage direct current, which is typically around 10 kilovolts. These represent the energy levels of our helium and neon atoms. When we turn on the power supply, energetic electrons travel through the gas mixture and transfer energy to the atoms. Since the gas is mostly comprised of helium atoms tend to absorb most of this energy. So, this energy excites the helium atoms to the energy level of 20.6 electron volts, which is the metastable state of helium. At this point, the helium atoms would collide and transfer energy to the neon atoms. When this occurs, the excited helium atoms would return to the ground state, while the neon atoms would be pumped to the similar metastable state of also 20.6 electron volts. Population inversion has now been achieved in the neon atoms, where more atoms reside in this metastable state compared to this energy level and the ground state. After a while, the neon atoms will spontaneously fall into the next lower energy state, in the process releasing a photon. This process is called a spontaneous emission. Now, this photon has the ability to come back and stimulate the transition of another neon atom from its metastable state to the next lower energy state. As shown, an identical photon is released during this transition. This process is called a stimulated emission. And since the photons we've been talking about are identical, all of these photons are capable of causing more stimulated emissions. To complete the cycle, neon atoms in this energy level eventually fall back to the ground state, releasing energy that is absorbed by the glass walls. This is what consecutive stimulated transmissions look like. When the intensity of the photons are high enough, some of these photons will escape the chamber through the partially reflective mirror, forming a laser beam.